Hi, in this video we will see how to use buffer function. Here I have a few shape files. One is the rain gauge points which we have prepared early in earlier class. Another is the Maharashtra outer boundary, and one more is a water body. Okay. So let's first talk about this rain gauge points. So these rain gauge points are spread over here. Part of them are located in Maharashtra, part of them are located over here on this part in Karnataka and maybe Telangana. So for example, if I wanted to know whether these rain gauge stations are sufficient to cover the entire surface, entire topography, and by some research, this is now a purely hypothetical case, by some research you come to know that a rain gauge station represents an area equivalent to 50-kilometer radius. Then by following this norm, I would like to check which part of this region is adequately covered, and in addition I would like to know in which part I should install additional rain gauges. Okay, so I'm repeating the situation. So these are the rain gauges, and I'm trying to see whether these rain gauges are adequate enough in terms of measuring precipitation in this region. And by some research I came to know that this rain gauge represents one rain gauge represents a surrounding area which is equivalent to a radius of a 50-kilometer. So therefore I wanted to know the area covered by each of the rain gauge. So then only I will be able to know whether these rain gauges over here are enough, or do I need to install more. So let's do it by using a tool called buffer. So it is available in geoprocessing tools, buffer. Okay, so for that you have to enter a rain gauge point, enter a shape file which can be a point, line, or a polygon, and then you have to mention a distance. Now here the distance unit is in degree, and we know the distance is not measured in degrees, and therefore this sign is indicated over here. The reason is obvious, because my rain gauge points data is in a CRS following the geographic coordinate reference system. Therefore you can see it's APSG 4326. Okay, so first of all, before performing this operation, I have to convert it into a projected coordinate reference system. So let's do it first. So what I will do, I will right click, I will export, save feature as, I will ensure that all features are selected, then I will click over here and I will say rain gauges UTM, save, and then I will change the CRS, I will change it to 32643. Since I have used it before, it is available in a drop down menu, otherwise I have to search it from over here. Okay, I will say okay. Okay, so I will remove now my earlier file. Okay, so these are the new rain gauges. Okay, now the question, let's run a buffer function on this vector geoprocessing tool buffer. Yeah, now you see over here there is no issue. So right now this I have selected this layer which is already in UTM, that is a projected coordinate reference system, and I have to select a distance over here, and distance is always in meters because we have seen it in the projected coordinate reference system. Distance is measured in meters. So the norm says 50-kilometer radius is enough, so I will put as a 50, but I have to convert it into kilometers, so I will say 50,000. So 50,000 meters. For a time being, just neglect this, and let's okay, uh, let's run this operation over here. Hmm, yeah, so this is the buffered layer which has created. So you can see over here, uh, let me put it, bring it down. Yeah, now you can see these are the this is the point, and this is the area which is covered by each rain gauge. So here I come to know that how much area is covered. So now I know that this is the area where I need to install additional drain gauges, this is the area I might need additional drain gauge needs to install, and so on. Same buffer function can be used from a toolbox, processing toolbox. So I will type buffer over here, and it gives me option buffer. Okay, vector geometry, I can open it from here. Yeah, the same window I can open. So here I am going to perform the same operation, but now let us assume that the new research says no, the rain gauge now covers, because there might be some advances, and therefore this rain gauge now covers, let us say 80 kilometer. So I am doing a perform the same operation again. Okay, so I am putting over here 80,000. Okay, just one thing I'm changing over here, this is something which is I'm ticking this box called dissolve units. Let's see what happens. And then I'm saying run. At present in this operation I can also store the file, so I will store the file, save to file. I will say buffer with 80 kilometer range, save, run. Okay, so this is the buffer. So what's the difference between the earlier operation and this operation? Let's remove, let's put it at the top, let's remove rest of the things. Yeah, in earlier operation the boundaries of each buffer zone were intact. When I click on dissolve, these boundaries get a dissolve. So now I cannot see the individual boundary. So depending on the requirement, you can also choose this of dissolving the boundaries. So now I came to know that these are the areas where I need to install additional rain gauges. So in this way you can use the buffer. So now we have used the buffer for the point data. See, this buffer has a multiple application. Right now we have seen in case of rain gauges, but for example in case of urban areas, for a time being, let's imagine these dots are, let us say, uh, representing a healthcare center, and let's say there is a norm that in a let's remove this bag, let us assume that this is located in somewhere in urban area, therefore I have removed the Maharashtra background. Now let's assume that these points are representing healthcare center, and a norm says in a given density of population healthcare center should be present, can be served only population within a 5 kilometer radius. So in that case, if I know the location of healthcare center by using a buffer function, by putting a radius of 5 kilometer, that is a 5000 meter, I can check how much area is covered by the healthcare center. So I can identify the location of new healthcare center. This can be used for also commercial purposes. For example, these are the locations of the shopping malls or the supermarket chain, and so, and it is the and marketing studies shows that, for example, this is a pure an assumption that supermarket serves an area of 3 kilometer in this locality. So by using buffer function, I can identify the how much area is served by the supermarket, and then accordingly I can identify how many new supermarkets are required and what are their key locations. So in this way, this buffer function can be used for in a multiple ways depending on the applications where you want to go. For example, this can be also be a location of a drinking water well in a village, and I can say that, for example, there is a norm that, let us say the norm is that drinking water source should be there at a distance of, let us say, 100 meter from the household. So I can see if this is the data is available, I can draw a buffer circle of a radius 100 meter, and then I can see how many households are served by each of these drinking water source, and then I can identify which are the residential areas which are not which are beyond the buffer zone of 100 meters. So I can identify the locations of the new water sources so that people can avail the water supply services. So this is the way buffer function is used, and we have seen it uh, in this video. Thank you.